intensive features means the amount is not going to be changed by changing the mass or volume. For example, density. Density is constant if we have 1 kilogram of that fluid or we have 100 kilogram. Okay? So by changing the mass or by changing the volume, the amount of this specification is not going to be changed. And we call it an intensive feature or a specification. And we have another type of extensive specifications. Extensive, something like mass. By changing the volume or by changing the mass, the amount is going to be changed. Okay? At critical point, here, intensive specification of the gas and liquid are the same. Okay? That's why it's important. And by knowing and finding this critical point, we are going to understand that the reservoir is going to be in gas situation or liquid situation. It means the amount of oil or gas can be changed. Look at here. We said that we are going to find an envelope here, and if you wanna follow it, this point is called B, this point is called D, this point is C, and it will come to E and A point. All of these different points are important for us, and we are going to find out what are the definitions of them. Till now, look at here, this is the critical point, and we talked about it. The critical point is the point at which the intensive specification of the gas and liquid are the same, okay? But this point D is called Crick-Condon bar point. What does it mean? Look at it. We said that inside this envelope, we are going to have two phases. Okay? It means gas and liquid are available. But at this section, we are going to have just liquid. So point D is called Crick-Condon bar, and this is the highest pressure at which liquid and gas can be available. So if we find a pressure higher than Crick-Condon bar pressure, we can say that always that fluid is in liquid situation. Got it? Did you get it? That's why point D is important for us. Crick-Condon bar point is the point at which, or it's the pressure at which, at higher amount of this amount, we can just find liquid. Okay? That's why it's important. If we know what is the Crick-Condon bar pressure, we can understand that at what pressure we are going to have two-phase fluid and at what pressure we are going to have one-phase liquid. Another point which is important is here. And this is called Crick-Condon term point. Crick-Condon term is the highest temperature at which, at higher amount of this temperature, we are going just to have gas. Okay? So, if we know what is the temperature of the reservoir, and if we compare it with the Crick-Condon term, we can understand that if we are going to experience two-phase liquid or just one-phase gas. Got it? Is it clear? Hassan, did you get it? So, that's why these two different points are important. And we know what is the critical point. Now, guys, this line is important for us. BDC line. This line is called bubble point line. What does it mean? Look at here at the previous section. This line we are talking about. suppose we have constant pressure, okay? By increasing the temperature, we are going to move forward and get near to these lines, okay? When we reach to this temperature, for example, we can assume, for example, 200 degrees of Celsius and a pressure about 100 bar, okay? At this point, the first bubble of the gas is going to be formed, okay? That's why this point is called bubble point line. The first bubble of the gas is formed at this line. That's why this line is important for us. Before that, we are going to have just liquid, and at this point, we are going to see the first bubble of the gas. So we are entering a two-phase region. Got it?
Yes.
So this is called the bubble point line. This line is important for us too, and this is called dew point line.
Dew point.
Yeah. And suppose a situation that you are going to have constant pressure and you are going to decrease the temperature of the gas. Okay? When temperature of the gas at constant pressure is going to be decreased, we will reach to this line. And first droplet of the liquid at dew point line is going to be formed. Again, we are going to enter the two-phase region. That's why bubble point line and dew point line are important for us, because when we reach to them, we are going to experience two-phase liquid.